Oh, hey guys. Hang on a second. Hey guys, welcome to the channel. Now, today's debate is between Professor Dave and David Weiss. And David Weiss, of course, being from DITRH. A bunch of flat earth nonsense, a bunch of bullshit that he believes. He even has that stupid app that doesn't even work. But of course, those who are flat earthers, of course, will swear by it. But Professor Dave does a very, very excellent job calling out David Weiss's bullshit. Tries to stifle him at every turn, gives an explanation for the things that David Weiss doesn't quite understand. And his housekeeping questions, David Weiss's housekeeping questions at the beginning, I'm sure you can tell, are actually ways to try to get Professor Dave a bit on his side, if you really want to believe it. But none of his questions are really yes or no answers. Now, Professor Dave does an excellent job calling all of his bullshit out, and David Weiss just ends up calling him a dick towards the end. I want to give a special shout out to my subscriber, Your Pal Al, who suggested me cover this debate. Thank you, Your Pal Al. It's very much appreciated. Now, if you guys give me a couple minutes so I can get back to clean up the rest of the bullshit David Weiss left while I was covering this debate and cutting it on the editor. All right, so sit back and enjoy. I'll see you guys next time.
Congratulations on your YouTube success, man. 2 million subs. That's phenomenal.
Thank you.
Yeah.
This is the first time I think a real flat earther, I'll call myself a real flat earther, has spoken direct with Professor Dave, as he normally does videos, you know, that just go out and pretty much straw man us, whether you know it or not, or gaslight us, and then there's really no way to respond because...
No, so you've never seen my channel ever and have no idea what I do because I make academic tutorials.
I have, but your flat earth stuff is is gaslighting us, essentially.
It's devastating and destroys flat earth easily.
Absolutely. So
started big straw man. Oh, he says that they think the earth is flat. What a straw man.
I'm with you. Listen, I don't mean to come off that way. Would it be okay to look for some common ground? Can I just ask a couple of quick questions, Dave? You good with that?
Whatever you want to do, man.
Yeah, I'm just for, you know, to see if we have any common ground. Do you believe we went to the moon?
Yeah.
Okay. Do you believe that governments are here, especially the American government, for the people's well-being?
It's a pretty complicated question.
Okay, you don't have to answer it. That's fine. That's good. Do you believe that there's censorship going on YouTube?
Yes.
Some stuff is deprioritized in the algorithm. I don't know if that qualifies as censorship.
And is the news here to inform or to fill us with propaganda?
The news is largely propaganda. None of that has anything to do with the shape of the earth, so I don't know what the hell you're even talking about. Literally none of that has to do with the shape of the earth. So you're really off to a bad start already.
Just looking for some common ground, that's all.
Oh, so if we both don't like the government, therefore the earth is flat.
What is gravity?
You want to go first, Dave, or you want me to go?
Oh, okay. This is how we're doing this? Okay, so according to general relativity, it's the curvature of space-time around massive objects. And so this is one of the easiest ways to know that the Earth is a sphere, because everything we see, everything, including the Earth, right, very large, massive objects are crushed into a sphere. That's why stars, planets, moons, everything pretty much is spheres. So you can now go ahead and do your like electric gravity bullshit, and then I'll explain to you why it's stupid.
Well, the question is, does anybody any scientists or anybody that's ever proven that any of the luminaries we see in the sky are even physical, let alone spheres?
Yeah, we can see them in telescopes.
You can see them. So you believe that if you see something, that'll tell you its shape. So when I look at this, are these spheres? Oh. Are these spheres? Dave, are these spheres?
Yeah, no, I've seen this little trick, and I know the third one from the left is flat.
It's showing you.
Here's the problem.
One from the left is flat. Dave, give me a second, then you can go.
No, because I've seen you do this, because I watched 2 of your videos, and you say the same crap.
So how do you know what shape the moon is? How do
Okay,
you know
so
that the moon is even a physical object?
here,
Because
here's
during a new moon, no one
yeah,
sees
I
the
get
moon
it.
in the sky.
I know your talking points. So this works because that's not moving. The things in the sky move. So if you take the third one from the left, which I know is flat, and you move it around, it's going to start to change shape. Now, the other problem is it's not just about shape, it's about other things like composition. Do you know what spectroscopy is?
Yeah, spectroscopy is you can measure gases, but it has to be in a container. Where's the container?
No. Stop. We're looking at light. We're looking at light, and we are understanding about the materials, right? We're understanding the composition of things based on light. So when you start talking about gases, you show me immediately that you don't even know what spectroscopy is. So you do not know the ways in which we figure out things about celestial objects. You literally don't even know the definitions of the words that represent the techniques that we use. So why are you even talking about it?
Spectroscopy needs to be in a container. Otherwise, you don't know what you're looking
Spectroscopy needs to be in a container. The study of how light interacts with matter needs to be in a container. What does that mean?
Otherwise, when you're looking at the moon, you don't know what gases you're seeing in between us and the moon.
Gases? The moon is solid. The moon is a solid object.
How do you know that the moon is solid? How come you can't see it during a new moon?
Why can't you see it during a new moon?
Yeah.
Because do you understand how vision works?
Well,
right? In a new moon, what's happening in a new moon? The light from the sun is illuminating the side away from us.
So
right? Light illuminates the things that it hits. So a new moon is when the side that the sun is illuminating is the other side away from us.
During a total solar eclipse in your world, the Earth is a full Earth from the moon's point of view. It's bigger and shinier, and it should light up the moon, but it doesn't, and no telescope, from any position with infrared or anything has ever seen the moon.
Can you think of why? Can you think of why? Can you think of a much, much brighter object that is right there where the moon is?
Well, during
the corona of the sun, which is thousands of times brighter. What you're doing right now is you're basically saying, I'm going to shine a spotlight directly into your eyes, and then you tell me if you can see a firefly 2 centimeters to the right. Like, what are you talking about? Do you seriously not understand this stuff? A child can understand this stuff.
So when you're throwing out words like spectroscopy, what's the difference between spectroscopy and astrospectroscopy?
Excuse me, the fuck did you just say?
What do you mean, astro? So astro is a prefix that means stars. So if that's even a word, it's spectroscopy pertaining to stars. What are you, like, Googling stuff furiously over there?
In reality, an infrared camera, a regular camera from the space station, they should be able to see the sun, the moon, either approach the sun, eclipse the sun completely, or exit the sun, and nobody has ever seen it. So again, why are we looking up in the sky?
I just explained. I just answered your question. You just answered it again. You asked a question that I just answered. The sun is very bright, right? Way, way, way brighter than Earthshine. Do you understand that if something very bright, you're looking at something very bright, you can't see something way less bright next to it? What are you not getting about that?
In reality, an infrared camera, a regular camera from the space station, they should be able to see the sun, the moon, either approach the sun, eclipse the sun completely, or exit the sun, and nobody has ever seen it. So again, why are we looking up in the sky?
I just explained. I just answered your question. You just answered it again. You asked a question that I just answered. The sun is very bright, right? Way, way, way brighter than Earthshine. Do you understand that if something very bright, you're looking at something very bright, you can't see something way less bright next to it? What are you not getting about that?
Space is not as depicted, displayed in media, movies, etc. Flat Earth, Dave, do you want to start with that one?
Yeah, I mean, space is, they're just, giving us images of insanity in space. Like when they show us, nebulas, right? They show us this, and they tell us this is where stars are born. This is where there's gas and dust, so much of it that it's creating stars and spitting them out like ping pong balls, where they go run away and they park themselves in the rest of the galaxy. This gas and dust in space, in a vacuum, in zero pressure, how does that work? How come this doesn't collapse in on itself? This is just
It does. That's how stars are born. Yeah, they do collapse. It's how stars form.
Dave, in your world, this is gases are collapsing upon themselves and then
Yeah.
igniting themselves in a vacuum, in a vacuum, and then they
This
burn
is no,
for
no, no.
billions
Stop,
and
stop.
trillions of years.
Look, I know that you want to just spew your script without anybody challenging, but you say so many
I have no
stupid things,
script, David.
and I'm here to tell you why everything you're saying is stupid. So when you say stars igniting in a vacuum, the reason that's confusing for you is that you think stars are little bonfires
No, I
because
don't.
you're a moron. Because
No,
you don't understand nuclear fusion.
you think that
Nuclear
the-
fusion is the process by which stars glow. They're not little fireballs. And
So,
you
Dave-
can learn that by Googling something for 5 seconds, but you don't do it.
Dave, you believe that all the rocky bits turn into perfect balls, and then all of the gases somehow start getting gravity, and they start pulling it together, and they
Start
get so
getting
big.
gravity? What do you
Well,
mean start
how-
getting gravity?
How do they grow into stars? How come the dust is accumulating? What's bringing it together? Is somebody pushing
Gravity.
it up like a snowball?
Gravity.
So yeah,
Yeah.
and somehow it's pulling all of these gases together and turning into a nuclear furnace that burns for billions of years. I'm sorry, that doesn't make any sense. And if you
Okay,
want to believe that, that's your world.
so centuries of brilliant astronomers versus nuh-uh. Is that really all you have? Is the entire field of astronomy and you going, I don't like it. That's dumb. I'm dumb and I don't get it. So astronomy is wrong.
You never met these men. You don't know anything about these men other than the stories that the controllers of this world tell you.
You know they
Aristophanes-
wrote books, right?
Well,
You know
so
they
Arist-
wrote books that
so-
we can read, and then
so-
we base astronomy on that and do astronomy every day, right?
Dave, try not to interrupt. Aristophanes figured out the shadow. Eratosthenes figured out the diameter, the circumference of the Earth with his sticks and shadows. But nobody in that area that came out of that, other mathematicians, never wrote any books about him. They ignored him. They just never mentioned it, and then all of a sudden it shows up in the 1900s in books that go into the
that's
education
not true.
system.
I mean, if you're just going to lie,
wait,
then
wait,
we can just play the lie game.
And Dave, what about the fact that proves nothing? It works perfectly on a flat Earth. Sticks and shadows prove the Earth is flat. He also believed that the Earth was geocentric and we had an infinitely far sun. And so that sun is orbiting around a minuscule,
far?
Well, infinitely far. Infinitely far means so far away that the rays come in parallel. And that's a whole nother problem. But how is a distant sun orbiting around a speck Earth in the middle of space? That doesn't make sense. And they didn't think about
what
that.
Doesn't make sense? What doesn't make sense about an Earth orbiting a sun? What
No.
going that
No, you
doesn't
didn't
make
hear me.
sense?
Dave,
Isn't an argument.
Dave, stop being a dick. Listen to what I said.
You stop being a dick.
The Eratosthenes believed that the Earth was geocentric, that the sun orbited us, but the sun was a distant sun. How does a distant gigantic sun orbit a minuscule speck Earth? Okay? Yeah, you have no answer for that.
They don't know. It's the ancient Greeks. They didn't know. Now we know, right? We figured out heliocentrism in like the 16th century. You're trying to oversimplify things. You're trying to go, oh, it's crepuscular, it's all parallel, and so then this time it works for my talking point, and then another time it doesn't work for my talking point.
My point is Aristophanes' story doesn't make any sense with a distant sun orbiting a geocentric Earth.
Yeah, if you just say it doesn't make sense and stop talking, I guess.
How does a distant sun orbit a geocentric Earth when the Earth is tiny and the sun is gigantic?
Well, it doesn't.
In your
Long
model.
story short, it doesn't. Yeah. But so he was an ancient Greek, and he didn't know heliocentrism. They didn't know when Newton developed Newton's law of universal gravitation. He didn't know why massive objects attract one another, right? He just said, "This is what happens," and I have this equation, and we use Newton's equations to do all these incredible calculations that predict the motion of objects on Earth and in space. He didn't know what gravity was. Einstein gave a better explanation. The curvature of space-time warped around massive objects. We're probably going to get a better model later. Just that we don't know why things happen doesn't mean we can't do science at predictive power. So as it turns out, Eratosthenes and Ptolemy, the Ptolemaic model, was wrong. Heliocentric model is correct. It doesn't matter that they didn't know that part, or that they didn't know why something happens. Do you not understand how science works?
I'm asking you if you believe that the sun's gravity has no effect on moons.
Yeah, it had. You can calculate. You can see. This is what real scientists and people who understand science can do calculations. So instead of you going, I don't believe it, what you could do is you could take Newton's law of universal gravitation and take a moon, whatever moon, if you want to talk about our moon or one of Mars's or one of Jupiter's or whatever, and you could calculate a number that is the gravitational attraction between the sun and whatever moon you're talking about. And then you could do the same thing for the moon and its parent planet that it is orbiting. Which number do you think is going to be bigger, buddy? Which one do you think is going to be bigger?
And so
the planet, the one that it is orbiting around.
When we have a planetary alignment where all the planets are lining up, all of that gravity.
Hang on. You know what? Sorry. I would like you to actually just address what I just said, because this is what happens is I say something, or a flat earth debunker like myself says something that just annihilates the idiotic thing you just said. And then you just gish gallop to another point. I would like you to admit that what you just said is stupid based on what I just said.
I'm reiterating what you say to show you how stupid it is. It's holding on to the planets, but the sun's gravity, it can hold on to the planets, hold on to distant planets, but can't affect those moons at all.
Can't affect? Like I just said, you can do a calculation. Did you want to do the calculation? Do you want to do it together? Do you want to learn something today? So when you have a moon that is right near a planet, the gravitational effect is way more than the faraway sun. Isn't that neat? Isn't that a neat thing that we can do with math and numbers that are real things that scientists do, instead of just going, it doesn't make sense, so that's dumb.
You done?
Yeah. What do you got? Do you want to address this thing, or do you want to jump right to another thing?
I want to jump to something else, because you say that the sun's gravity that can hold on to Neptune and Pluto can't affect the moon, which is way closer to it, and that the Earth's gravity overwhelms that. That's stupid. That's me saying it.
Why?
You're the
all you're saying professor. Is that's stupid. All you're saying is that's stupid.
And all you're saying is that it works because I could do math, but it doesn't. It doesn't work.
What do you mean it doesn't?
Dave, model it. You know about the 3-body problem? I'm sure you know about that.
Oh, the 3-body problem. So we can't do
Dave,
calculations.
Stop being such a condescending prick. We already know. Just talk normal.
Why would two people on a flat pizza land look at the sky and see a sky that is rotating in different ways? Next one. And furthermore, why can't we all see the same stars? There are stars that you can only see in the northern towards the northern hemisphere, and stars you can only see in the southern hemisphere. Next one. On a globe, this makes perfect sense. If you're in the northern hemisphere looking at the North Pole, east is to your right. If you are in the southern hemisphere looking at the South Pole, east is to your left. Next one. And the reason we can't see certain stars is because you can't see through the Earth. Next one. That's why in the northern hemisphere we can't see the Southern Cross. That's why in the southern hemisphere we can't see Polaris. Next one. Almost done. Quick one here. So it actually gets a lot worse than that in the southern hemisphere, because you've taken a globe and you've unwrapped it. The southern hemisphere makes absolutely no sense. People in the southern hemisphere who are all looking at the Southern Cross are somehow supposed to be, we're believing that they're all looking in completely different directions and seeing the same object often at the same time. Next one. So again, on a globe, south actually means something. People who are looking south are all looking at the South Pole. They're all looking in the same direction, so that's why they all see the same thing, such as an object like the Southern Cross.
So in your world, we have people standing upside down, and you're assuming hemispheres on a sphere.
What do you mean upside down? What do you mean upside down? What does that mean?
Compare their feet are antipodal to my feet, people in the South.
Okay, so yours are upside down compared to them. What's the difference? What's down on a globe?
I'm not saying. I'm just saying people are upside down to each other halfway across the world. So if we can go back to the original slide so I can remember all the points he made so I can address them, that would be fantastic. So no matter where you are in the world, all of the stars, all the lights in the sky from things that we call planets, wandering stars, sun and moon, they all rise in the east, set in the west. If I'm standing on a flat Earth looking out to the south, the stars are coming from my left. If I'm standing in the north, looking at the north, the stars are coming from my right. That explains the opposite direction.
No, you just explained the globe model. You didn't explain anything.
You don't understand.
On the flat Earth, how do people see the sky rotating in different directions?
Because
explain
you're
that.
facing in different directions, David. So getting back to your point where you have somebody in Santiago, somebody in Johannesburg, and somebody in Australia, when they see the Southern Cross, well, they don't see it at the same time. They see it 12 hours apart from Santiago.
They don't see it at the same time? So people looking south can't see the night sky at the same time?
David, if you understand what the flat Earth model is, if somebody's in Santiago...
You don't have a model.
Listen.
Yeah.
Stop being a dick. Okay.
You stop being a dick. Your entire existence is being a dick to all of science. So stop telling me to stop being a dick. How about you go 4 hours apart? Why don't you go 4 time zones apart? They should still be looking in completely different directions. 12 midnight, 4 a.m., night sky, both looking south, both can see the Southern Cross. On your pizza world should be looking in completely different directions. Explain that.
Dave, when the only time that can happen is in Johannesburg and Santiago, and if you add magnetic declination in there, they're both looking in the same direction.
Magnetic declination?
Yeah.
So you think just saying the word magnet is going to be an argument here that's going to work for you?
Look up the magnetic declinations of those areas. You don't know what direction you're facing, right? There's certain areas of Antarctica that the magnetic declination is 170 degrees. So when your compass says north is that way, it's 170 degrees the other way, according to, NOAA or whoever's in charge of that, right?
Look, you can dress it up however you want. We're talking about looking this way and looking that way, and they see the same thing. And you're fixating on Santiago and Johannesburg because you think that they're far enough apart that they're not going to both be nighttime. I'm telling you, you can go any distance apart. Just go from Perth to Sydney, right? That's far enough apart that if you're both looking directly south, you're looking in different directions, and you can see the same thing. You cannot explain that. That's why you're trying to throw out jargon to confuse people, right? Are you denying that longitude lines, everybody on your pizza world is all looking in a completely different direction when they look south?
NASA or NOAA, they tell us, what longitude lines are you talking about? They tell us that the magnetic declination is a different direction. So we're listening.
Do they, or are you just randomly grasping at words to try to make sense of something that is absolutely unexplainable for you?
David, it's not true. And the optics in the sky, again, do not prove the shape of the Earth. You say that they do.
I just did prove it with that, so I don't know what to tell you.
Let's move on.
What talking point?
We hear you, but we don't care.
What talking point are we on right now?
I just finished proving the Earth is a sphere by looking at stars, something that we've been doing for thousands of years.
Yeah, so says you. Go ahead.
Yeah, and everybody who's ever lived. So NASA isn't going to really help you with that one. Sorry, buddy. They started in the 1950s.
A talking point from Dave, which is the Bible has 200 references to the flat Earth. Every major ancient civilization cosmology depicts the Earth as flat.
That's from me or from Dave?
That is
I would
from
never say
you,
that.
I think.
That's not from me. That's not from me.
It's from Ash. It's from Ash.
Yeah, I mean, if you're a Bible believer, from page 1 in the Bible, it says God separated the waters from the waters and created the firmament. That's all interesting, but I don't use the Bible as science because science will show us on a ball Earth, Dave. Yep. You have to have a physical horizon, right? If my fingernail is a boat, as it goes away, it disappears below a physical horizon, and zooming in will not bring it back. However, we can see too far. And with infrared, now we're seeing things 500 to 1,000 miles away. The amount of curvature.
No, you're not.
Yeah, we are.
Not.
Go look at Jay Tolan Media's channel.
Go look at some lies that a flat earther said. That is real evidence.
No, it's Dave. It's well documented. You haven't looked at it. And then when you say the curvature formula is a parabola, I absolutely agree. It is. Over 1,000 miles, it gets off a little bit, but anything under 1,000 miles, all three formulas come within a very close proximity of each other.
Yeah,
right?
but the problem is you can't do math, so you just do the math wrong.
Well, you just say that, but if you look at all of the curvature formulas under 1,000 miles, it's perfectly accurate. And then you think that we're spinning at 1,000 miles an hour and we don't feel it, and we're changing, we're changing directions. How is that possible? How about when the Earth comes around comes around towards the sun in the winter, in our northern winter, it's speeding up and taking its sharpest turn. And then we don't feel any of those forces.
It's sharpest turn. Okay, so this one's really hilarious to me. So the sun goes around the Earth, the Earth goes around the sun in how long? How long does it take?
A year.
A year, right? So why don't you go ahead and get in a car and do a 360 turn and make it take a year? Are you going to feel that?
Dave, that's not a
Let's break it down. 360 degrees, 365 days. That's about a degree a year, right? Why don't you get in a car and drive for 24 hours and over 24 hours veer by 1 degree? Are you going to feel that?
That would be equivalent to this. People say, "Oh, I'm just trying to think of the easiest way."
I'm just trying to think of something to say
Hey,
that
Dave,
will make
stop,
sense.
Stop being a dick. All right. Imagine if you want to compare that,
man.
if you want to compare that to reality, imagine you're in an airplane where you remove the outer shell of the airplane, you double the speed of the airplane, and you nosedive 2 miles a minute. Okay.
Oh.
And that just to follow the curve of the Earth. That's the speed that the Earth is curving. And when something's moving and it's curving, that's acceleration. Okay. So
big words.
Acceleration's a big word.
When it is for you because you're not using it properly. So, acceleration is rate of change in velocity. So you're using it like it's velocity.
When you change
so
off
you don't
of
know
your
what
vector,
acceleration
when
means.
you change off of your vector, that force is equal to acceleration. Your mainstream science says that because of the spin of the Earth, because of the centrifugal force, that the water bulges at the equator 14 miles high.
What?
This is what Neil deGrasse Tyson and science tells us about the spin of the Earth. The water at the equator, yes, it does. It bulges 14 miles high. It makes the Earth 29 miles wider at the equator.
No, that's the Earth, not the water. What are you talking about? Are you a moron, dude? The radius. This is what happened. You're very confused.
So let me ask you a question.
No, stop, because you just said a very specific number, and I know why you said that number. The diameter of the Earth is about 27 miles greater at the equator. That's the whole Earth. You're trying to pretend that it's all water, that there's just this big thing of water that's 14 miles. Is that what you're genuinely trying to say? Are you that stupid?
Well, that's what Neil deGrasse Tyson says. But let's
he didn't say that.
I'll go with you. The Earth is bulging. So does that mean that large bodies of water at rest near the equator, if you hung a plumb line over it, that it wouldn't be perpendicular to the surface of the water? It would be off just a little bit.
Okay, a bulge isn't. First of all, as I just said, this has nothing to do with the water. It's the shape of the Earth itself. So you're just completely wrong anyway. But second of all, what this is the thing with you guys. You think that the curvature of the Earth is supposed to be? You're talking about a plumb line. Do you think that the curvature of the Earth is supposed to be like this or something? Do you have no idea how big the Earth is? Do you not understand that the curvature is not detectable at the surface of the Earth? It's really big. It's a really big planet.
Horizon. We can see boats go over the horizon. We can see boats go over the horizon, but we can't see the curve, right? Dave, according to your math, there's certain things that should be behind a curve at certain distances, but we can see too far.
But we can't. You just lie about them. You just said earlier that we can see things 1,000 miles away. Are you out of your mind? Everybody should be able to take a telescope then and see something 1,000 miles away. Why can't they?
Dave, you don't know where it was taking it from. It's infrared cameras. Go look at JTOL and Media One and watch all of the. He's
the special one. He can do it. Nobody else can do it.
Actually,
Nobody else can get this footage. So, but they don't.
Dave, let me ask you a question.
They just don't because they don't feel like it. I think what you're trying to ask is if you have parallel planes, right? If you have two flat planes, can they be made parallel? Yes, two flat planes can be made parallel. Well, what are you saying? Because nobody has any clue what you're saying.
If you have a horizontal line on Earth, then there's only one point that would be touching the Earth, and the rest would just rise up into space. But all horizontal lines line up with the horizontal horizon. Okay, they're all parallel.
Do they, or do they just look like that because your eyes suck and they can't distinguish between arc seconds of angle?
My question is, the top of the World Trade Towers, when they were up, are those floors larger than the lower floors? Because for them to be perpendicular, they would have to get larger, right?
How far apart were they? How far apart were the towers?
I don't know, but I'm asking you about one tower.
Okay, but it doesn't look. It doesn't matter. We're talking about the distance between the towers or the width of a tower. Do you know how much curvature there is over such a small distance? It is so small that it is 100% negligible. What are you not understanding about that? The Earth is really big. They're not lines, right? They're not actual lines. Do you know that lines are just approximations, right? We can draw lines, we can graph lines and do math in perfect Euclidean geometry. The Earth has a spherical surface. So yeah, we can go, that's a line and that's a line. And if we're just looking at less than a mile, yeah, it looks really straight. But it's not, because the Earth is a sphere. So you're not comprehending scale. That's the problem.
Has anybody measured curvature in large body of water at rest? A large body of water needs a container to hold it in place. And has anyone measured any curvature on resting water? And don't
Okay.
me your drop and your wave, which is in your stupid video that got 10 million views.
Drop and wave? I don't even know what you're talking about.
We talked about water curves, and you showed a drop of
Oh,
water.
yeah. Okay, no, I know what you're talking about.
That is just a complete straw man.
Well,
nonsense.
it's not, but actually, this is what's funniest to me is that your flat Earth, you debunk yourself with this level water thing, because the funny thing is that so tides exist, right? And so on your little pizza world, tides are these little mounds of water that kind of travel around. I don't really know how else you're going to explain this, but right, tides exist, right?
Yeah,
so
but
on your little pizza world,
you
you've got a
believe
little
that
hold on, you've got a little mound of water that's just kind of traveling around. So I'm sorry, but water isn't level on your pizza world either.
Dave, what causes your high tides? The moon?
What causes tides? The moon.
Yeah.
And well, there's solar tides and there's lunar tides.
Right. And so when there's a new moon, which means the sun and the moon are on the same side of the earth, the tide should be bigger, but there's not. There's bigger tides when they're
No, it
opposing.
is.
No, they're not.
No, it is.
You're absolutely wrong.
No, I'm not. And you
right.
can Google it right now. What are you
Okay.
talking about? When the solar and lunar tides align, that's the highest tide. Well, unfortunately, you can't do the like Antarctica isn't real, so the South Pole, that's not a thing. These are places where
we
people
don't say
live.
Antarctica is not real. We don't say that at all. You say
No,
that.
you say the South Pole isn't real,
We don't.
even though there's people who go there and work there. And
people work at the South Pole.
yeah,
Yeah, prove it. Okay. So
you can get a job there. Did you know that civilians can get jobs?
So the way it
You
works,
should apply for one. I think that'd be a cool video for you to
Dave,
do.
on your upside down world, on your ball world, in the north, Norway and northern Alaska, we have the 24-hour sun in June. Okay, and we see the sun, and it's been filmed by millions of people, and you can watch the sun circle around. Makes perfect sense on a ball. Makes perfect sense on flat Earth. We're on the same page there. But 12 months,
Yeah,
6
not
months,
really, but
6 months later. 6 months later, at equal southern latitudes, you should see the same. But there's no video of the. No, you don't. There's no video of the 24-hour sun. There's 3 or 4 fake videos, clearly fake, taken apart. I'm talking, right? I didn't interrupt you. But if you add a dome in there, and again, we're looking at the lights in the sky, which is something that doesn't prove either. When you bring the sun closer to the dome, it wraps around, and we could show you this. Get a dome, get a glass, move the light, and you'll see that the light wraps around, and that's exactly what we see in Antarctica.
Okay, so I know that you can do your fun little middle school science project where you have a little, serving tray thing and you make a flashlight do funny things, but you cannot make it actually. So this is why you have your dumb little app, your little thing and your sun and stuff. It doesn't actually show the regions of actual daylight and nighttime. It just shows like a little cartoon. You don't actually see. It doesn't actually do these patterns. So when you're called out on this, instead of going, oh, my app shows the actual patterns and this crazy arc that would make sense. So first of all, I'm sorry, even though there are videos at the South Pole, I'm sorry that Antarctica is not where a bunch of people live. So we don't have all of these videos like we do way up towards the North Pole. I don't think you understand what I just said.
No, you don't understand what I just said.
No, I definitely know that you're not saying anything. I'm saying that in that town in Argentina, there is an objective time where the sun rises and sets.
Yes,
and
but
where you are doesn't change that.
There's no place that you have 17 hours of sun. You have daylight. Daylight is the illumination of the sky. It's not the sun.
From the sun.
No, the sun is.
You're saying that daylight is not from the sun?
Absolutely. So if the sun
where is it from?
If the sun
What's
rises,
making the sunlight then?
No. The sun is lighting up the sky. It's like a photographer. You have your main light, and then you have your backlight. The sky is the daylight. When the sun is on the east side of your house, right on the horizon, go to the back side of your house. You can read the newspaper. Well, where's that? That sunlight's not. What's it going through your house? It's lighting up the sky.
It's scattered by atmospheric particles.
That's what
you say.
It's still
sunlight.
Yeah.
Well, that's what you say to say a thing that
Dave,
explains why what I just said is stupid, and I have no way to combat it.
How come nobody has filmed the 24-hour sun in Antarctica?
They have. Just say it's a lie.
Dave, the optics of the sky are no way to prove the shape of the Earth.
They are.
Yeah, well,
and I just did it twice.
Yeah,
and you have no way to combat anything I just said.
With a local sun, in like the flat Earth is, we have no shadow here, and we have a shadow here, and then you could do your math and figure out what the sphericity of this flat plane is, right?
Okay, so for that to work, how close is the sun?
How close is the sun?
How close is the sun?
Yeah, the
Really
sun.
close, like right
sun-
above the clouds, which we'd be able to see if you went up in a plane or a balloon, and
wanna
it'd
hear
be
my
like right
answer?
there. Huh?
Dave, there's tons of videos explaining how the sun is an apparent object, and we all see it in a different position.
Oh, there's
wherever
videos
we are.
that say
There-
dumb things,
No,
so
no,
it's
there's
true.
that show science, show experiments, and when you try to triangulate the sun, there's a problem. You can't do it. You can't triangulate the sun. So how far the sun is? Some flat earthers say it's 3,000 miles away. I don't like that answer. The math works. We can scale it and make it
The
6,000
math
miles
works.
away.
You've never done any math in your entire life. You
Hey,
just
hey,
say
Dave,
the
Dave,
math works and expect
saying,
people to.
stop being a condescending prick. All right, try.
Why
Try
don't
for a
you
few
stop
minutes.
condescending to the entire human race and pretending that every scientist ever is a liar and satanic deceiver? That's much more offensive than me calling you stupid, which you
Dave,
are.